In this lecture, we're going to learn about the one definition rule. And this is a rule that says definitions can't show up more than once in your entire C++ program, or in some cases, a definition can show up more than once in a translation unit. We are going to look at the one definition rule in the context of freestanding variables, functions, classes, member functions, and static members in our classes. In most cases, a definition can't really show up more than once in your entire C++ program, but we have exceptions to this rule. And the exception is for classes. A definition for a class can show up in multiple translation units, and the reason is we need to create objects of those classes, so each translation unit really needs to see the definition for the class. And we are going to try and make this super clear with examples once we hit Visual Studio Code. Okay, so it is time to head over to Visual Studio Code and shed some more light on the one definition rule. Here we are in our working folder. The current project is one definition rule. We're going to grab our template files like we always do. We're going to put them in place, and we're going to open this little guy in Visual Studio Code. Let's do that. We're going to drag and drop, and we're going to have our main CPP file here. We're going to clean it up. That's what we always do. And now we want to explore the one definition rule in the context of variables. So we have a freestanding variable here, and that's going to be the same variable we had in the last lecture. We're going to initialize this. And this is really good. We can use it. We can go in main and use it however we want. We can print the weight. And if we build and run this program, it is going to work. But the one definition rule says we can't have more than one definition for anything. And for this variable here, we have seen that this is both a declaration and a definition. So we can't have more than one definition for the weight name here. For example, if we try and grab it and copy and paste it here, so we're going to try and build this program. We're going to use GCC. We're going to see that we have a problem, and the problem is going to say redefinition of double weight. And it is not going to help even if you take this and put that in another file. So let's create another file to really show you this. We're going to call it some other file, .cpp, and we're going to grab our redefinition and move that there. And you're going to see that if we try and build this program, we're going to get the same problem. We're going to have redefinition. So we're going to see, what is the problem here? The compiler error is a little bit different, but it is going to say multiple definitions of weight. And it's going to say one is defined in the main CPP file. So this is a linker error. This was caught by the linker because the redefinition is showing up in multiple files. So the linker was linking this program and it needed to see a definition for weight, and it had seen one definition in the main CPP file, and it has seen another definition in some other file, and this is a problem. The linker doesn't know which one to choose, so it's going to throw an error. And you can't really have multiple definitions for a variable in your C++ program. And this is the one definition rule in the context of freestanding variables like the weight here. But this is the same in the context of functions. If we go down and put up our add function here, we're going to say double A and double B here. And we're going to put the definition below the main CPP file. Let's grab this. We can copy this and put this in the code here. We're going to remove this little thing. We don't want it. We're going to put in our body, and we're going to return A plus B here. Okay, so this is our function. It is working. We can take out what we had here because it has served its purpose. We can say double result, and we're going to add up 10 and 20 like we did in the last lecture. No problem. And we can try and print out our result here. If we build and run this program, it is going to work without a problem because we only have one definition for the add function. What is the problem here? We have weight defined multiple times. We're going to comment out one definition for weight, and we're going to build again. Now the build is good, and we can run this program. We can kill our terminal here and bring up another one and run Rooster. You're going to see that the result is 30. And the program is working just fine. But if we set up another definition for add, even if we put this in the same file, we're going to get a problem because we are violating the one definition rule. Let's run again. You're going to see the problem here. We're going to see redefinition of the add function. This is not allowed. Your program is not going to compile. We see the compiler error here. Even if you put the definition in another file, that's not going to help. We're going to take this and put this in some other file and try to compile the program. We're going to get a linker error, and it is going to say multiple definition of the add function, and this is not allowed. This is a linker error, and this time, if we comment out one definition, let's do that. We're going to comment out the one in the main function. This is going to work, and we want to be violating the one definition rule. So this is good. The build is good. We can clear and run Rooster. We're going to see our result here. So the one definition rule says you can't have multiple definitions for freestanding variables or even functions. And we saw that if you do that, you're going to get a compiler error. Let's look at this in the context of classes. We're going to do a class. We're going to say struct, and we're going to call this point like we always do. Mostly, we're going to call this point, and we're going to put in a few member variables. One is going to be mx, the other is going to be my, and this is going to be our definition here. But what you're going to see is that it is possible to have multiple definitions for classes. For example, if we take this and have a copy of this in another file, we're going to do that. We're going to declare this structure here, and we're going to try and build this program. You're going to see that it is working. We have multiple definitions of these guys. We can go in main, for example, and say point p1, and we can build and see that the program is going to work. Okay, so if you go in here, for example, and try to print std cout p1 and print x, we're going to do that. We're going to say p1 mx. We're going to be able to use this because this is a struct. The member variables are public by default. We can do this. And we can say p1y is p1y, my. Let's do that. And we can say stdndl. What is the problem here? We need to put our output stream operator. I think now the compiler is going to be happy. And if we build, we're going to use GCC. We're going to see that if we run the program, we're going to see our things here, and we have some junk values inside because these things are not initialized. But if we initialize them to 0 using braced initialization here, we're going to build again, and we should see 0 inside. So let's clear and run Rooster. Now we have 0 in x and y for our object here. This is working fine, and we have multiple definitions for our class. But the definitions can't show up in a single translation unit. For example, if we took this definition here and brought that back in main and put that just below our struct here, if we try to build, the compiler is going to complain because now we have multiple definitions for the same class in the same translation unit. For classes, we can have multiple definitions, but the definitions have to show up in different translation units, and that's what I want you to see here. So we have a redefinition of our point struct, and it is not good. It is going to violate the one definition rule. Okay, now that you have seen this, we also want to see this in the context of a class that also has some static member variables. We're going to take this out because you have already seen this, and we're going to bring in our person class like we used in the last lecture. We're going to add in a new header file. It's going to be called person.h, and we're going to jump into, what did we do? Is this a folder? Let's remove this. We didn't want a folder. We're going to delete this folder. We don't want it. And we're going to just add a file called person.h. That's our file here, and we're going to put in the content. The content is going to be our person class. Let's close this so that you can see more of this class here. Okay, so we have our person class here. We have our include guard. We have our person class definition. We have a constructor, and we have a printf function. We have our member variables, and down below here, you see that we have a static variable, which is person count. we need to put in the definition for these guys. So let's go down and do that. We're going to put in the definition for the person constructor. We're going to go on top here and include our person header file, and we're going to put in place our constructor. We can go down and do that. We can say person and say person. That's going to be our constructor. We're going to go back to the class and grab the parameters because I don't want to type all this. Thanks. So let's do that. We're going to put them in. We are going to put in our initializer list. I think we should also delete a parenthesis here. We're going to go down and put in our initializer list. We're going to say full name. We're going to initialize this with name param. And we're going to also put in our age, and we're going to initialize this with age param, the parameter we have from the function. And this is going to be all. Inside the body, we're going to increment the static variable. We're going to say increment person count. We can select that here, and this is going to be good. We also need to initialize our static variable, so we're going to say int person count. Let's do person count, and we're going to initialize this to maybe 8 like we did in the last lecture, and this should be all we need here. So if we build and run this program, I think it's going to run. Let's select the main function here. And what problem do we have here? Let's build and see. We're going to let the compiler figure this out. We're going to see that the build is good, and we can create person objects and really use them in our program. So let's come down here and delete whatever we had. We're going to include person, and we're going to go down here and create a person object. We're going to say person p1, and we're going to specify the name to be Jon Snow. Why not? And we're going to say that they are 35. Why not? And we can print information about this person. We can say person printful. And if we try to build this program, let's use GCC to do that. The build is going to be good. As you see down here, we can clear and run Rooster. We're going to see Jon Snow. He is 35 years old. So this is working just fine. But we can't have multiple definitions for the same class in the same translation unit here. For example, if we come in the main function, notice we are including person. So this is bringing in the definition for person we have in our person.h here. If we also try to declare another class called person, even if we don't put anything in, the compiler is going to complain because we have two definitions for the same name, which is person here. If we try to build, I think we are going to get a compiler error saying that we have a redefinition. You see, we have a redefinition of person. So this is not allowed. We can't really do this. But notice that this person class is included both in some other file, which is a separate translation unit, and main. We have it included here. So it is really in a separate translation unit. We have the definition for the class in separate translation units. And that's not a problem. But if you try and put the same definition multiple times in a single translation unit, you're going to get a problem, and you need to be aware of that. What I want you to see right here is that you can't also have multiple definitions for your static variables and the member functions of your class. For example, if we grab what we have here, and also put that in our main function, we can do that. Why not? We're going to come in our main function here, and we're going to put the same definitions here. Now we're going to have a problem because the linker is going to see two definitions for the static variable and the constructor for person here. And this is going to be a problem. You can't really do that. If we build, we're going to see a problem. We're going to see that the problem is we have multiple definitions for the constructor, and we have multiple definitions for person count, and this is not allowed. You can't really do that. You can either remove the one from some other file .cpp, for example. If we comment this out, let's do that. We can come on top here and comment this out and try to build the program. Now the program is going to work because we have one definition for these guys. You see the build is good. We can even run the program to show you that it works, or we can remove the one in the main CPP file and we can leave this alive. So let's go back in the CPP file, the main CPP file, I should say, and remove this. And if we build, we're going to see that this is going to work. And we are compliant with what the C++ standard expects us to do in our C++ programs. If we run, we're going to see that this is going to work. And this is really cool. This is really all I wanted you to see in this lecture. The one definition rule, which says that you can't have multiple definitions for the same name in your entire C++ program. But for classes, we can violate this rule a little bit and make the same definition show up in multiple translation units. We are going to stop here in this lecture. In the next one, we're going to learn about linkage. Go ahead and finish up here and meet me there.